All right, so this question is asking you to find the derivative dy dx of, again, an inverse trig function. I am not a huge fan of memorizing those inverse trig function derivatives. Again, I know you can do that, but I really like to tackle this, just based on my knowledge of inverse and then also my knowledge of implicit differentiation. So ultimately, when I look at this problem, I realize that I actually can't take the derivative right now. I'd love to go ahead and just be able to differentiate with respect to x, right? Because that would ultimately give me dy dx there. The problem is I get stuck right there, right? Like I don't have that memorized. So what I'm going to do instead is I'm going to change this so that it's not inverse sine anymore. I'm going to go ahead and change it so it's just normal sine. Now, before I can invert this function, right, I can only invert the sine function. I can flip around its inputs and outputs. But that 2 is problematic for me. And so what I really have to do is I need to be able to switch around the input and the output. So this is the input, and this is, right now, this looks like it's the output, but it's really not, because that 2 is actually, kind of modifying it. So if I kind of move that 2 over, right? Not like that. If I divide by 2 on both sides, I can then go ahead and see this function as being y over 2 equals inverse sine of root of 1 minus 2x squared. Now, seeing it this way, now I can see, here's my input, and then here's my output. And I can just kind of flip-flop those when I invert. Another way I could have tackled that too is I could have just ignored it and just dealt with the inverse sine function. And then in the end, since I know that I'm doubling that function, I would know that I'm doubling dy dx as well. So I could always have done that and just kind of ignored it temporarily. But I started this way, so let's go ahead and do that. So now that I know that this is switching around the input and the output, I can go ahead and write this as sine of y over 2 is really going to be equal to the root of 1 minus 2x squared, because I'm just flipping around my inputs and outputs. And this is something that I can take the derivative of with respect to x. And again, keep in mind, I always like to make my triangle for my trig function, because this is really going to help me when I'm tackling some other stuff. So I know the angle is y over 2, and I know that the sine ratio is root of 1 minus 2x squared all over 1, right, because I want to see it as a ratio. And so that really tells me that this is 1 minus 2x squared, and that the hypotenuse is really 1. And so I can see it in this way. Okay, so now that I'm here, I want to go ahead and take the derivative of this. So I'm going to go and take not with the eraser again. I'm going to take the derivative of this. And I'm going to take the derivative of this with respect to x, because I want dy dx. So I need to take the derivative with respect to x. So I'm going to go ahead and do that. And I know the derivative of sine is really going to be cosine of y over 2. And then I realize that I have to take and implicitly differentiate, because there's layers here, right? Like I'm taking the derivative with respect to x, not y. And so when I take the derivative of that internal layer, I would really get times 1/2 dy dx, right? So there's that. And then on the other side, chain rule it up, baby. All right, so again, keep in mind I kind of view it as 1 minus 2x squared raised to the 1/2, right? So it's going to equal 1/2 multiplied by 1 minus 2x squared to the negative 1/2, and then I have to take the derivative of the inside, which is really negative 4x. And since I was taking the derivative with respect to x, I'm good. So, all right, I need to solve. Wait, what was I trying to do? I'm trying to get that, right? So I need to solve for that. Before I do, I'm going to clean things up. Clean up. So, right, because that's a factor on both sides. I could double both sides if I really wanted to. I'm going to go ahead and rewrite that right-hand side. It's really going to be negative 4x over the root of 1 minus 2x squared. And then, this is cosine of y over 2 times dy dx. And then, you know, I'm going to solve for dy dx, and I know dy dx equals negative 4x over, and it's going to be cosine of y over 2 times the root of 1 minus 2x squared. So there's that. Now this is great, and it's true. This is actually quality. The only problem for me there, right, is keep in mind that we have that y over 2 right in there. That's problematic because I should have dy dx solely in terms of x. So I need to know what cosine of y over 2 is, and this is when I can kind of return to my triangle, which I now need to really move because I ran out of space. Should have put it up there in the first place, right? So there's that. This is y over 2. All right, good enough. So I need the cosine of that, which means I'm going to need to find my adjacent side. So we go ahead and find the adjacent side. You know, if I find that adjacent side, like I realize, all right, 1 squared equals, well, I'm going to have that square root squared, so it's going to be net this. Plus the adjacent side squared. And so when I go ahead and subtract the 1 from each side and go ahead and add the 2x squared, I get a squared equals 2x squared. And so then I'm going to really get a equals, well, the root of 2 times x, right? I'm square rooting that. And so that's my adjacent side, the root of 2x. You know, not the root of 2x, but the root of 2 times x. And so so that my cosine ratio at this point in time, like, is adjacent over hypotenuse, which, you know, then I already have. So I can go ahead and finish this off, and I say that's negative 4x all over root of 2 times x times the square root of 1 minus 2x squared. And then again, I would probably clean things up, and I would get rid of that, you know. And then I might even clean up, well, one of those roots, but I don't really need to. You know, this is a usable form here, so ultimately, that's what I would do there. And hopefully that's what I have on the key. I'm going to go ahead and check real quick. And then, yep, it is. So, yeah, so hopefully this video helps you with, you know, looking at complicated inverse trig functions.